We'll continue in section 9.5, applications with quadratic equations. And we'll have quiz 9 tomorrow at about 8:40. And so to review for the quiz, work on solving quadratic equations using a valid method, either completing the square method or the quadratic formula, or if you can solve by factoring, that's also permissible. Okay, we'll work on this problem, number 7. This one will involve using the Pythagorean Theorem. So a pole perpendicular to the ground casts a shadow whose length is 1/3 the height of the pole. The distance from the top of the pole to the edge of the shadow is 20 feet. And with that information, we can find the height of the pole and the length of the shadow. So in a geometric problem like this, sometimes it's helpful to draw a picture. So we're told that we have a pole that is perpendicular to the ground. That means it forms a right angle with the ground. And we're told that the shadow is 1/3 the height of the pole. And the distance from the top of the pole to the edge of the shadow is 20 feet. So if we draw a line segment connecting the top of the pole with the end of the shadow, we're told that that length is 20 feet. Okay, so this is a right triangle, and we're going to be able to find the height of the pole and the length of the shadow by using the Pythagorean theorem. But let's make our variable assignments first. So the pole and the shadow. We can do it in more than one way. But since the pole is 3 times the length of the shadow, if I just pick x to be the length of the shadow measured in feet, so the shadow is x feet. And the pole is 3 times longer because the shadow is 1/3 the height of the pole. So the pole is 3 times x feet. And then you can verify by looking closely at your variable assignments and the information in the first sentence to make sure that it makes sense. Yeah, sure, it makes sense. X is 1/3 of 3x. Okay, so we have 3x for the height of the pole and x for the length of the shadow. So we'll review the Pythagorean theorem. If you have a hypotenuse with length c, and if the legs have lengths a and b, then the Pythagorean theorem says that if you square the length of the hypotenuse, that's equal to the sum of the squares of the lengths of the 2 legs. Okay, so we're going to do that with this right triangle. The hypotenuse is 20 feet. So the Pythagorean theorem says we square 20 feet, 20 squared. And that's equal to the sum of the squares of the lengths of the 2 legs. Okay, so here you'll want to make sure that you are careful. We have to square the term 3x, and we also have to square x. Okay, in the next line, 20 squared is 20 times 20, that's 400. When you square the term 3x, that's 3x times 3x, which is 9x to the second, and we're adding that to x squared. And then combining like terms, 9x squared plus 1x squared is a total of 10x squared. This is just a quadratic equation, but it looks like the easiest thing to do is to solve it by using the square root property. So I'm going to divide both sides by 10 and write this as x to the second equals 40, because 400 divided by 10 is 40. And in this problem, we want the positive solution. This equation has a positive solution and a negative solution, but in this problem, the positive solution is the one that makes sense. Okay, so if we just write the positive square root of 40 and then simplify that, the largest factor of 40 that's a perfect square is 4. So this is the square root of 4 times the square root of 10. And so x is 2 times the square root of 10. Okay, so the length of the shadow is 2 times the square root of 10 feet, which is a little bit more than 6 feet, because the square root of 10 is a little bit bigger than the square root of 9, which is, the square root of 9 is 3. So this is a little bit longer than 6 feet. And then the length of the pole is 3 times 2 times the square root of 10, or 6 times the square root of 10 feet. Okay, if you're supposed to round your answers to 1 decimal place or 2 decimal places, you can use your calculator and get decimal approximations. Okay, so make sure that you know how to use the Pythagorean theorem for right triangles. Okay, the next problem, number 8. The height h in feet of an arrow shot upward after t seconds is h equals negative 16 t to the second plus 320 t. Find the number of seconds it takes for the arrow to be at a height of 400 feet. Okay, so h represents the height of the arrow. T is measured in seconds. So what we're going to do, we're going to replace h with 400 and then solve that equation for t. Okay, so the height of the arrow will be at 400 feet, so replace h with 400. We have 400 equals negative 16 t to the second plus 320 t. Let's get this into standard form by adding 16t to the second to both sides and subtracting 320t from both sides. So the left-hand side will be positive 16t to the second minus 320t plus 400 equals 0. Okay, so this is just a quadratic equation in the variable t. So we know how to solve any quadratic equation. But we can make the process easier by noting that 16, negative 320, and 400 are all divisible by 16. So if we divide every term on both sides of the equation by 16, we'll get an equation whose solutions are exactly the same as the solutions to this one, but the numbers will be smaller and a lot easier to work with. Okay, so 16t to the second divided by 16 is just positive 1t to the second, or t to the second. And then negative 320t divided by 16 is negative 20t. So we write minus 20t. And then 400 divided by 16. Well, that's just 25, positive 25. So we have plus 25. So we'll just solve this quadratic equation. So on this one, a is equal to 1. B is equal to negative 20. C is equal to 25. Okay, so t equals the negative of negative 20. That's the negative b part. And then plus and minus the square root of the number negative 20 squared minus 4 times 1 times 25. And this is all divided by 2 times 1. Okay, so t equals, the negative of negative 20 is 20. And then plus and minus the square root of some number. And then all divided by 2. So inside the square root, the number negative 20 squared is 400. And we're subtracting 100. 4 times 1 times 25 is minus 100. And so we get 20 plus and minus the square root of 300 divided by 2. And then we'll simplify the square root of 300. The largest factor of 300 that's a perfect square is 100. And the square root of 100 is 10. So we'll write t equals 20 plus and minus. Okay, so this is going to simplify to 10 times the square root of 3, all divided by 2. And then a common factor of 2 will cancel. So this will become 10 plus and minus 5 times the square root of 3. So it looks like we have 2 positive solutions. So what does that mean? Well, that means that the height of the arrow was at 400 feet twice. Once on the trajectory upwards, it reached 400 feet and then surpassed 400 feet. But then on the way down, it was at 400 feet again. So if you can sort of picture what the arrow did, we can tell from how the function is defined that at time t equals 0, the height of the arrow was 0 feet above the ground. So it was at ground level. And so the arrow was shot upwards and then it came back down. So on the way up, it reached 400 feet. And then on the way down, it also reached 400 feet. So that makes sense. That's why there's 2 different solutions for t. Okay, we'll look at more application problems. Okay, so let's try this one. We did a work problem yesterday, but this one's a different one than the one we did yesterday. Working together, James and Mary can do the yard work in 8 minutes, When each works alone, Mary takes 12 minutes longer than James. Find how long it takes each to do the yard work alone. Okay, so we have three scenarios. James works by himself. Mary works by herself. And then they can work together. We're first told that when they work together, they can do the yard work in 8 minutes. So when they work together, James works at a certain rate. We add that to Mary's rate. And in 8 minutes, they can complete one job. So our equations have the form rate times time equals 1. 1 is the yard work. Okay, we don't know yet how long it takes James by himself and Mary by herself, but we do know that Mary takes 12 minutes longer than James. So we can pick a variable to represent the amount of time it takes James. I'll use capital T this time for the amount of time it takes James to do the yard work by himself. And Mary takes 12 minutes longer than James. So if James takes T minutes, then Mary takes T plus 12 minutes. So we have our rate times time equals 1 equation for all three scenarios. We want to know what T is, and then once we know what T is, we'll know what T plus 12 is. So we want an equation whose only variable is T. So if we solve each equation for the rate, James's rate is 1 over T. Mary's rate is 1 over T plus 12. And James' rate plus Mary's rate is 1/8. Okay, so we replace James's rate with 1 over T, replace Mary's rate with 1 over T plus 12, and those two add up to 1 over 8. So we get 1 over T plus 1 over T plus 12 equals 1 over 8. Okay, in chapter 7, we learned how to solve equations with rational expressions like this one. So the least common denominator is just 8 times T times the binomial T plus 12 over 1, if you want to write it that way. Okay, so when we multiply 1 over T times 8T times T plus 12, the T factors cancel, so we're just left with 8 times T plus 12. And when we multiply the least common denominator by 1 over T plus 12, the T plus 12 binomial factors cancel, so we're just left with plus 8T. And then on the right-hand side, 1 over 8, or 1/8 times 8T times T plus 12. This time, 8 divided by 8 cancels, and we're just left with T times T plus 12. This equation is just a quadratic equation in the variable T. So we'll multiply everything out, set one side equal to 0, and then we can at least use the quadratic formula. So on the left, 8 times T plus 12 is 8T plus 96, and then plus 8T. On the right-hand side, T times T plus 12 is T to the second plus 12T. Okay, so what we'll do, on the left-hand side, we have a total of 16T. So I'm going to subtract 16T from both sides, and we'll also subtract 96 from both sides. So we get 0 equals T to the second minus 4T because 12t minus 16t is negative 4t. And then we're also subtracting 96. Okay, so we can use the quadratic formula. Let's take this a bit further then. A is 1, B is negative 4, and C is negative 96. So T is equal to the negative of negative 4 plus and minus the square root of the number negative 4 squared minus 4 times 1 times negative 96. And this is all divided by 2 times 1. Hey, I appear to have run out of space, but I'll just translate that onto another sheet of paper. Okay, so now we just do arithmetic. T is equal to, let's see, the negative of negative 4 is 4. If you analyze what's inside the square root, you'll realize that the square root of this number is going to be bigger than 4. So the solution that we get by subtracting is going to be negative. And we don't want a negative solution, we want a positive solution. So I'm just going to write plus instead of plus and minus, because the only solution that makes sense is the positive one. And then inside the square root, the number negative 4 squared is 16. And we're subtracting 4 times 1 times negative 96, which is equivalent to adding 4 times 96. But 4 times 96 is just positive 384. And then we divide all of this by 2. And then 4 plus the square root of 400, all divided by 2. And the square root of 400 is 20. So we get 4 plus 20 divided by 2, or 24 divided by 2, which is 12. Okay, so T is 12. That's the amount of time it takes James in minutes, 12 minutes. James's time. And then for Mary takes T plus 12 minutes. So T plus 12 is 12 plus 12, or 24 minutes for the amount of time it takes Mary. Okay, that wasn't so bad. With a high-powered calculator, it'll be even easier. You just have to always be careful with the signs, the subtractions, and the negatives. Okay, let's try this problem, number 4. In a total of 10 hours, well, it says in 10 hours, Mitch paddled 24 miles up a river and back 24 miles. So if that's confusing, it means that Mitch paddled 24 miles up the river, and then he paddled back 24 miles, and he did all of that, the entire 48 miles, in a total of 10 hours. And we're told that in still water, Mitch paddles at 5 miles per hour. So we will find the speed of the current of the river. So once again, this is sort of unrealistic. In order to be able to solve this problem, we're going to assume that the speed of the current is always the same on that 24-mile stretch. I suppose that's possible, but another assumption is that Mitch is always paddling at the same rate, like a machine. Okay, but those concerns aside, we'll just solve it as if those things were actually true. Okay, so we have a couple of situations. Mitch paddles up the river, which is against the current, a distance of 24 miles. And then he turns around and paddles downstream for a distance of 24 miles. And if there was no current, if it was just still water, Mitch would be paddling at 5 miles per hour. And we want to find the speed of the current, so we'll just pick x to be the current speed, or the speed of the river in miles per hour. So Mitch is traveling upstream, which is against the current. I'll put that in parentheses, against the current. And then he's going to paddle downstream, which is with the current. Okay, so we're going to write down two equations, each having the form rate times time equals distance. Okay, when he's going upstream or against the current, well, he's going slower than 5 miles per hour because the current is holding him back a little bit. It's holding him back by the speed of the current. So the boat will be traveling at 5 minus x miles per hour. It's going slower because it's going against the current. And I'll put t sub u for the amount of time it takes him to travel a distance of 24 miles upstream. And then when he goes downstream, well, this time the boat will be going faster than 5 miles per hour. It will be going faster by the speed of the current. So the boat will be traveling at 5 plus x miles per hour. And I'll write t sub d for the amount of time it takes to paddle 24 miles downstream with the current. Okay, there's another important piece of information. We're told that the total time to go 24 miles upstream and then 24 miles back downstream, the total time is 10 hours. So this amount of time, t sub u, plus that amount of time, t sub d, is 10 hours. Okay, we want to solve for the speed of the current, which is represented by x. So that means we need to use our equations to come up with a single equation whose only variable is x. So we can do that if we solve each of those two equations for time. On this one, the amount of time it takes him to paddle 24 miles upstream is distance divided by rate. So 24 divided by 5 minus x. Solve the other equation for time, the amount of time it takes him to paddle 24 miles downstream is distance divided by rate, 24 divided by 5 plus x. And then this amount of time, 24 over 5 minus x, plus this amount of time, 24 over 5 plus x, adds up to 10. So that will give us our equation, 24 over 5 minus x plus 24 over 5 plus x equals 10. This is our equation whose only variable is x. Okay, so just like we did in chapter 7, the variable we want to solve for is in each of two denominators. So we're going to multiply every term on both sides by the least common denominator, and that's just 5 minus x times 5 minus x. If you multiply 5 minus x times 5 minus x, let's go ahead and do that now. 5 times 5 is 25 minus 5 times x. I'm sorry, I wrote one of those incorrectly. Let me change this one to 5 plus x. 5 plus x times 5 minus x. Those are the two denominators. So 5 times 5 is 25, and then minus 5 times x is minus 5x. And then plus x times 5 is plus 5x. And then finally, x times negative x, we write minus x squared. And the two middle terms cancel each other out, so the least common denominator is 25 minus x squared. Okay, I'm out of space on this page, so I'll quickly write this information on another piece of paper, and then we'll be able to look at it and do the rest of the work here in a minute, in a few seconds. Okay, so here we are. Okay, we're going to multiply every term on both sides of this equation by the least common denominator. So in factored form, if we multiply 5 plus x times 5 minus x times 24 over 5 minus x, the 5 minus x factors cancel, and we'll just be left with 24 times 5 plus x. Then we multiply the least common denominator by 24 over 5 plus x. This time the 5 plus x factors cancel, so we'll just have 24 times 5 minus x. And then on the right-hand side, multiply 10. This time I'm going to multiply 10 by the expanded form of the least common denominator. So 10 times the quantity 25 minus x squared. And then we'll just do algebra and arithmetic. 24 times 5 is 120, and then plus 24 times x is plus 24x. And then we have plus 24 times 5, which is plus 120, and then minus 24x. And on the right-hand side, 10 times 10 times this quantity 25 minus x squared is 10 times 25 is 250, and then minus 10 times x squared is minus 10x squared. Okay, this is just a quadratic equation. But notice on the left-hand side, the plus 24x minus 24x, those add up to 0. 120 plus 120 is 240. And so we get 240 equals 250 minus 10x to the second. So let's get this into standard form and then look at what we have. If I add 10x squared to both sides and subtract 250 from both sides, I'll get 10x to the second minus 10 equals 0. Okay, well, we have a number of options, but it looks like to me the easiest thing to do, since there's only one term that has x in it, the x squared term, if I add 10 to both sides to get 10x squared equals 10, then divide both sides by 10, I get x squared equals 1. And this equation has two solutions if we apply the square root property. The two solutions are positive and negative square root of 1, or x equals positive and negative 1. But in this problem, only the positive solution makes sense. The speed of the current is 1 mile per hour. So x equals 1 mile per hour. That's the speed of the current that we were looking for. Okay. All right, we'll do more examples. So let's try this one. The product of two consecutive even integers is 288. Find the integers. Okay, consecutive even integers differ by 2. So we can pick x and x plus 2 to represent the two integers. And then we're told that the product, x times x plus 2, is 288. Okay, so we can, this is just a quadratic equation. So if we multiply x times x plus 2, we get x squared plus 2x equals 288. And, well, we have multiple options. We can put this into standard form. If we subtract 288 from both sides, then we can use the Pythagorean Theorem, or sorry, the Quadratic Formula. But I think what I'll do is I'll just use the completing the square method, because the coefficient of x squared is already 1. So x squared plus 2x equals 288. If we take 1/2 of 2, which is 1, and then square 1, 1 squared is 1. If we add 1 to both sides, then the left-hand side is now a perfect square trinomial. So when we factor x squared plus 2x plus 1, we just get x plus 1 squared. And 288 plus 1 is 289. And then we can apply the square root property. So x plus 1 is equal to positive and negative square root of 289. And the square root of 289 is just 17. 289 is a perfect square. So in our next step, we can write x equals -1 plus and minus 17. Okay, this equation has two solutions for x. One is x equals -1 minus 17, or -18. And the other solution is x equals -1 plus 17, which is positive 16. Okay, but notice what the directions are. It says the product of two consecutive even integers is 288. It doesn't say that they both have to be positive, and it doesn't say that they both have to be negative. So we're going to have two sets of numbers. So let's do the negative ones first. X could be negative 18. And then if x is negative 18, x plus 2 is negative 18 plus 2, which is negative 16. So one pair of numbers that satisfy the conditions, negative 18 and negative 16, those are consecutive even integers, and when you multiply negative 18 times negative 18, you get positive 288. But then there's a positive pair of solutions. The positive solution for x is positive 16, and then the other x, the x plus 2, is 16 plus 2, or 18. Okay, so that makes sense under the conditions of the problems, that we have two sets of answers. Okay, in the next problem, the area of a triangle is 40 square feet. So we did a triangle problem yesterday. So remember, for any triangle, we can assign one side to be the base. And as soon as we assign one side of the triangle to be the base, then there's just one height that corresponds to that base. So the height is the line segment that connects the vertex of the opposite side of the base, which is perpendicular to the base. And then the area of a triangle is just 1/2 times the base times the height. Okay, so we're told about a particular triangle that has an area of 40 square feet. And we're told that the base is 2 feet longer than the height. Okay, there's more than one way to make a variable assignment for both the height and the base. But I'm going to pick x measured in feet to be the height. This seems a little bit easier to me because the base is described in terms of the height. So if I pick a single variable for the height, then I'll just use the other information to find an expression for the base. Okay, so the base is 2 feet longer than the height. So this isn't too hard. Since the height is x feet, 2 feet longer than x is x plus 2 feet. Okay, then we use our variable assignments in the fact that the area of the triangle is 40 square feet. In this formula, replace area with 40 square feet equals 1/2 times the base, x plus 2, times the height. Okay, this is a quadratic equation in the variable x. So we can proceed. It seems like the easiest thing to do, if we want to get rid of this fraction, just multiply both sides by 2. So 2 times 40 is 80. 2 times 1/2 is 1. And then 1 times x plus 2 times x is x squared plus 2x. So we have another quadratic equation. This would work out nicely if you solved it by completing the square, but we did that in the previous example. So on this one, let's just put it into standard form by subtracting 80 from both sides. And we'll practice using the quadratic formula. So I'll write the quadratic formula here. X is equal to negative b plus and minus the square root of b squared minus 4ac, all divided by 2 times a. Okay, so for this one, a is 1, b is 2, and c is negative 80. So x is equal to negative 2 plus and minus the square root of 2 squared minus 4 times 1 times negative 80, all divided by 2 times 1. And then negative 2. So here we're in a situation, again, we can tell ahead of time, since inside the square root we have 2 squared, which is 4, and 4 minus negative 320 is 4 plus 320. And the square root of that is bigger than 2. So the solution we get by subtracting is negative, but we don't want a negative solution. We want a positive solution. So I'm just going to write negative 2 plus. I'm going to ignore the minus one. And then we have the square root of some number all divided by 2. Okay, so as we observe, negative 4 times 1 times negative 80, that's negative or minus negative 320, which is the same as 4 plus 320, which is 324. Okay, and the square root of 324, that's just 18. 324 is a perfect square. So that works pretty nice. So we'll write negative 2 plus 18 divided by 2. Negative 2 plus 18 is 16, and 16 divided by 2 is 8. Okay, so the height of the triangle is 8 feet. That's what x is. So 8 feet is the height. And the base, 8 plus 2, is 10 feet. And we can take it further just to make sure it makes sense. The area is 40 square feet. And the area is 1/2 times the base times the height. And sure enough, 1/2 times 10 times 8 is 1/2 of 80, which is 40. So everything checks out on this one. Hey, we've covered just about we've covered every problem type in these applications that we wanted to cover. Some of them we've covered more than once. So if you practice those problems that we've covered yesterday and today, then you should be in good shape for test 4. Test 4 will be a week from tomorrow. So I guess that's all for today. And remember the quiz tomorrow.